Welcome to our lecture online. Just like there are two equations to calculate permutations, there are two equations to calculate permutations. And notice that the only difference between the equations for permutations compared to the equations for combinations, wow, those are just mouthfuls, hard to keep pronouncing those words, is simply the difference of 1 over r squared. Notice if I take this away, that's the equation for how to calculate the total number of permutations. With this, it becomes the total number of combinations. Same with this equation. If I get rid of the denominator, notice that would be the equation for the number of permutations, and with that becomes the number of combinations. Now, we're going to use the same example to show how this works. Notice that we have a license plate of 4 characters, non-repeating letters, that's typically what we use, and the order does not matter, so yes, indeed, we're dealing with combinations. So, how many total combinations? We have 26 letters to choose from, 4 are picked, and they're non-repeating. So that means that the total number of combinations of 26 available letters and 4 are picked, that is equal to n, which is 26, times n minus 1, 25, n minus 2, 24, and eventually, if n is 26, notice we get 26, minus r is 4, plus 1, that's equal to 23, so the last one here is 23. There should be 4 there because we have 4 characters, and then we divide that by r factorial, which in this case is 4 times 3 times 2 times 1, because r is 4. Notice we end up with the exact same result as last time, and in the previous video, and so if we calculate this, we get 26 times 24 times 26 times 25 times 24 times 23. So we end up with 358,800 divided by 24, because 24 is equal to 4 factorial. So divide by 24, and we get 14,950 total combinations. And so you can see that either equation will give you the very same result, because notice that if you start to work this out like we did in the previous video, we end up with the same kind of multiplications and division. So you can see the same result regardless of which equation you use. So therefore we have two handy equations to calculate the number of combinations, and that is how it's done. I need some coffee.